Very much for joining us this morning for this it's quite quick run through electric vehicle charging. The main purpose of this presentation will be to concentrate on domestic size and light commercial size systems. So we're not going to get into too much detail about the sort of large commercial systems you'll see on motorway service stations and those kind of areas. But more, sort of practical things that we can all get involved in our day-to-day lives. Although obviously I will touch on all the different systems. Just a quick piece of housekeeping before we start. Just to let you know that as of the 5th of May, so next week, we are moving all these webinars onto the MESHWORK. So you will need to go through MESHWORK in order to sign up for the webinars. There will no longer be Eventbrite links for these webinars. So if you're not on MESHWORK already, then get over there. You just joined, go to meshwork.meshenergy.com and sign up on there. It's free.
Hey Richard, right, sorry about that. I'm just gonna put myself on mute.
So get yourself over to MESHWORK and get yourself signed up. It's free to use, and we will get going. Okay. So what we're going to cover today. So basically, a quick introduction to Mesh Energy. I'm sure many of you know who we are already, so I'm not going to spend loads of time on that. Some of the basics around EV charging. So, what is EV charging? Why do we need it? Why would you even have an electric vehicle in the first place? And then why would you have a charging point at your home and office? You don't have a petrol station at home, so why would you have an EV charge point at home? A few bits of definitions and terminology, and a bit about AC and DC electricity. Then we're going to get into the real tech. So a bit about charge point types, connector types, electrical safety, load curtailment, solar PV integration, and also a little bit about the future, which might be vehicle to grid power. So where you're taking power from the car battery and using it to run your house. And then we'll get into some of the sort of more paperworky sides. So there's a couple of grants that we'll look at, which you can get from the government. And then a little bit about what you need to talk to the electricity companies about, the DNO permissions. And then finally, a little bit about time of use electricity tariffs, which can be quite advantageous to EV owners. And then finally, we'll cover off a few of the key points, a little bit more about Mesh Energy themselves. And then we'll have a short piece on questions. Okay, so without further ado, let's crack into it. If you have got questions as we're going through, please pop them in the chat. I will try and pick them up as we're going along. So let's go. So who are Mesh Energy? So we are a small independent consultancy. We're based in Farnham in Surrey. We are independent and all we do really is energy consultancy and mechanical and electrical services consultancy. But our main aim is to simplify the whole sort of green building landscape. So that could be everything from how to choose the best building materials, which are sustainable, all the way through to full M&E designs, making sure that everything's going to fit, all that kind of stuff. We try and take it from end to end. And although we don't do any installation ourselves, we have got a whole network of installers that we can recommend to people who are interested. Okay, so let's talk about some of the basics of electric vehicle charging. So an electric vehicle charge point, which is what we're going to talk about most today, is effectively just a designated specialist electrical outlet designed to charge electric vehicles. So that's battery powered vehicles or what are called plug-in hybrid electric vehicles. So those are vehicles that have both an electric power source that can be charged from the mains or from an electric vehicle charge point, and have an internal combustion engine, which is usually a small petrol engine. Electric vehicle charge points vary in their design and their power output depending upon their intended use. So as I mentioned earlier, I'm not going to get into the sort of super fast chargers too much that you get in motorway service stations. But what we'll concentrate on is the smaller chargers that you'd find at homes and offices, which charge a little bit more slowly. So that is really 7 kilowatt single phase charge points, which are typically used at home, and 22 kilowatt 3-phase charge points, which are used in sort of more commercial environments. So why use an electric vehicle? Well, electric vehicles offer several advantages over fossil fuel vehicles. They also have some downsides, so we'll look at the downsides in a second. So the first and main advantage is they have zero tailpipe emissions. So assuming you get your electricity from renewable sources, it makes driving zero carbon. They have lower running costs than an equivalent fossil fuel power car. They have lower maintenance because there's fewer moving parts, fewer things to go wrong. And they have actually really good performance. So it's one of the concerns people have. They think back to milk floats from the 1970s, and they think that's what an electric vehicle is. Actually, because electric motors give very high torque at low RPM, they actually give very, very good performance, especially from a standing start. And of course, they have a good image as well. Although it's not something that I particularly think is of importance to me, I know it is of importance to some people, and it does project a certain image, a certain green image. So what are the downsides? Well, there are definitely a few downsides to electric vehicles. The first one is which is the range that you can actually drive on a single charge. So typically your range would be around about 150 to 200 miles, that kind of thing with most electric vehicles. Some have a longer range, some have a shorter range, but that's the kind of range you're talking about. For most people, I think the average amount that people drive per day is about 8 to 10 miles. It's not a huge distance. You're driving to and from work, you're going to pick the kids up from school, those kind of things. You're going to the supermarket. So actually having a limit of 150, 200 miles is really not a big issue for most people most of the time. Recharge and refueling time. Well, yes, I mean, if you flatten the battery, then it does take longer to refuel than just pulling up to a petrol station and sticking the nozzle in. But that's offset by the fact that most people have chargers at home. Battery replacement. Batteries have improved quite a lot since the early electric vehicles. The batteries on those typically lasted about 3 years. The latest electric vehicles, you're looking at about 10 years battery life, and then you need to have a replacement. And there are question marks about the environmental impact of mining for some of the battery materials. So it is definitely something to worth considering when you're buying an electric vehicle, is where have they actually source those materials from. So the next thing that people always ask is, well, okay, I understand about the range thing, but how long does it actually take to charge an electric vehicle? And that clearly depends upon the charger you're plugging it into. So for most electric vehicles, they're going to be charged at home with a single phase 7 kilowatt charger most of the time. So you normally charge them when they're not in use. So it's a slightly different kind of scenario. Obviously you don't have a petrol station at home, so you are always going to be refilling your petrol car when you are out and about doing something. Whereas with an electric vehicle, you're typically charging them when they're not being used. You're not having to leave home to do it, or you're not having to leave the office to do it. So a fast charger, so a 7 kilowatt charger, would recharge a sort of typical 40 kilowatt hour Nissan Leaf from fully empty to fully charged in about 6 hours. Now, obviously, that typically would be done overnight. Could be done during the day when you're at work. But the other thing to remember is you're very rarely going to actually completely empty the battery, because it's not like a fossil fuel car where you wait until the red light comes on the fuel gauge, and then you go to the petrol station, you fill it up. You're continually topping the battery up because it's easy to do, and you've got that fuel station there with you. Rapid chargers, which are the very sort of high power chargers you can get at motorway services, will typically give you a faster charge rate of approximately 100 miles in 35 minutes. So you're on the motorway, you're on your long journey, you nip into the service station to get a cup of coffee, go for a pee, and you plug your car into the charger. In the sort of 35 minutes that it takes you to get your coffee, get your sandwich, whatever you're doing, you should have added about 100 miles to your range. So that gets you, a fair way up the motorway. I mean, I think of sort of the longer journeys that I do, it's pretty rare that I'm driving more than 250, 300 miles in a stint. Even going up to Hull or somewhere like that, Leeds, it's you're talking, not talking about a huge journey. And realistically, if you're going further than that, you're probably going to be looking at alternative transports anyway. But of course, if you really need to, you can always hire a fossil fuel car if it's a really, really big worry. So having an EV charge point at home or office offsets most of those potential downsides. So obviously you can top up little and often, and the charge costs, because they're low, they're much lower than the cost of fueling a car with fossil fuels. You can do that through cheap electricity at home, which you might get from your PV. And you can do that by making use of surplus PV and through some clever charging tricks that I'll show you a bit later on. So the one other thing I wanted to talk about before we get into the actual charging points themselves was about the difference between AC and DC electricity. These slides you may well have seen in other presentations we've done, but I'll just run through them quickly. So AC electricity is what you get out of the mains, and it's not suitable for directly charging a battery. So when you plug your electric vehicle into an AC charge point, actually what happens is that the AC goes into the car, it's then converted by the onboard charger in the car into DC, and that's what charges your battery. DC electricity, which is what you get out of the big superchargers at the motorway services, is direct current, and that rapidly charges the car, but it comes direct in from DC. It's also actually the type you get out of photovoltaic panels, but you usually have to convert that DC from the PV panels into AC and then back to DC again in the car to do anything practical with it. Okay, so let's get into some of the tech. So first of all, what's the actual charge point look like? Well, this is a typical domestic charge point. This is the Zappi. It's probably the charge point that we specify on most of our jobs. It's probably not the prettiest thing in the world, but it has lots of features, which is why we like to specify them. So it's either called an EV charge point or an electric vehicle supply equipment, but basically it's just a machine that supplies the electric vehicle with energy. They can supply AC or DC, as I said. Typically, for what we're looking at for sort of light domestic, for domestic and light commercial, we are looking at AC chargers. This Zappi is an AC charger, so what comes out at the end of that plug is AC, and that is a 7 or 22 kilowatts, depending on whether it's a single phase or a 3-phase charger. The actual Zappis actually look identical in both options, and they can supply a range of different power outputs. Usually, what happens is the car itself will limit the charge rate, as well as the controls coming from the electric vehicle charge point. And they can have a range of different connectors and plugs, and we'll look at some of those in more detail a bit later on. But for domestic size applications, almost all vehicles now have a Type 2 plug, which will show you what it looks like in a moment. But there are different types of AC charging points. So the one you can see in the background of this is made by a company called Anderson EV. They are a little bit more expensive than the Zappies, but they come in a much wider range of finishes and things, and they look a bit sleeker. They have a really nice integrated cable sort of storage arrangement where it actually cleans the cable as well as you put it in and out. It's got little brushes that sort of sweep any dust or dirt off the cable. It's quite a nice looking thing. AC charge points in most homes and offices we'll use in most homes and offices, and as I said, 7 kilowatts for your home one and 22 kilowatts for a 3-phase commercial charger. Okay, then we get into the big boy stuff. So these are the sort of motorway service type chargers, the big DC chargers. So these are generally found in public car parks, taxi ranks, motorway services, those kind of things. They can charge much more quickly, but they're not really suitable for home and light commercial. Your power supply just won't take it, so it's not really worth thinking too much about these. They always have tethered cables, these units, but they are really designed for those sort of big, heavy commercial applications. So the two most common AC, and there's a typo in here which I've missed, types of connections are, in fact, I will just correct that now. So that should be AC. Are the Type 1 and the Type 2. You will also very occasionally see some very, very old EVs that have a third type of connector, but they're pretty much obsolete now. The Type 1 is increasingly becoming obsolete as well, because the Type 2 will do both 7 and 22 kilowatts. So some of the earlier Nissan Leafs had the Type 1 connector. I believe all the newer Nissan Leafs now have the Type 2 connector. You can get adapters to swap between the connectors if you really need to, but Type 2 are by far the most common. When it comes to DC connectors, which is the high power connectors, there's a few different options. Most of the connectors that you get will do sort of adapt between, so you have one input and you can plug either a Type 2 AC connector or a different type of, or one of the DC connectors in. So you'll see that a lot of the pin arrangements look very similar. And I can never say this well, CHAdeMO connector and the CCS connectors are probably the two most common, unless you happen to buy a Tesla, in which case you'll get probably one of the Tesla Type 2 connectors. But they're all pretty universal. And you can find both types of chargers at most major motorway services, so you can get the right type of connector for your car fairly easily. So let's talk a little bit about electrical safety. Now this is something that as a consumer and a designer you probably aren't going to get too involved in, but it's just worth understanding a few of the ins and outs of electric vehicle charge points and what they require from an electrical safety point of view. So these are all these regulations are covered in the wiring regulations, BS 7671. It's an enormous, I think it's grey, the current version of BS 7671 book, A4 book, about 400 or 500 pages or something ridiculous. But it's a bit of an odd one. So the first and most important thing is Rcd protection. So Rcd, an RCD measures the difference in current between what is going through the live wire, so and what is going back through the neutral. So if there's an imbalance between live and neutral, the RCD knows that there must be a fault current going somewhere, and that fault current, even if it's very small, could be enough to kill somebody. So it immediately cuts off the power supply in that event. So RCD protection must be used. It must be a type A RCD or better if you're getting into the really geeky stuff. The other point is that because a car is a big metal box that stood on a driveway, quite often outside a house, you must have some sort of independent earthing system, or you must use one of 5 methods to prevent to protect the user in the event of a protective earth and neutral fault. So as the electrical wire goes out of your house, the neutral and earth are connected together, which is a PEN conductor, protective earth and neutral. If that conductor was to break, potentially any extraneous conductive part on that system could become live. Obviously a big metal box like a car, you're stood on damp ground, you touch the car body and it's live, and then you've got to get a shock and kill you. That will not be picked up necessarily by RCD protection, because the fault could be outside, beyond where your RCD protection is. So it's really important that you either have your own independent earth rod, which is a TT system, or you have this PEN fault detection system. Now, this PEN fault detection system is built into some electric vehicle charging points. So one of the reasons we specify the ZAPI quite often is because it's built in. Those EV charge points that don't have it built in, you can buy a separate box that will do that PEN fault detection. But the vast majority of houses are on what they call a TCNS supply, which means it's T means tear for earth, N for neutral, NC for combined, and then S for separate. So it's separate within the installation, but combined outside the installation. And that is also called a PEN conductor. The other thing to consider is that obviously you're adding a brand new quite high load device onto your existing electrical system. So you've got to be sure that your existing electrical system isn't going to become overloaded by that. Now, the electrician who installs your electric vehicle charge point should do an analysis of what you've got already on the system and how much spare capacity you've got. They then have 3 options. So the first thing they could do is if there's not a sufficient supply, they could go to the distribution network operator and ask for an upgrade. Now, typically, if you've got a 60 amp single phase supply to your house, which is common on many older properties, then the DNO may well come and upgrade that to a 100 amp connection for free. The second thing that they could do, if they're unable to get an upgrade cheaply, or it's simply not practical, then they could limit the current that the electric vehicle charge point draws based on the load that's placed on the supply at any one time. So that sounds quite complicated, but in reality it's quite simple. All the electric vehicle charge point does is it measures how much electricity is coming in through the mains, and if that starts getting towards the limit, then it starts ramping the output of the charge point down, so that it keeps it within the limits. And the third thing they could do is they could just put a fixed current limit on the EV charge point. That's probably the least good solution, because all that's going to happen is that you're just limiting the capacity of your charger. Okay, so having talked about that, let's talk a little bit about the upside, and that is making use of surplus solar PV. So most people will export a fair proportion of the electricity they produce from their solar PV array, and an electric vehicle charge point is one way that you can really get the most out of your solar PV. So this all depends on the charge point you choose, and again, there's a really good piece of tech in the Zappi charger that we generally specify, which allows maximizing the maximization of solar PV output. But it's done by 3 modes of operation. There's a fast mode, an eco mode, and an eco plus mode. So I'm going to just go through what those 3 modes are. So first of all, there's fast mode. So fast mode is where you need the absolute maximum that you can get out of your charging point. You know, your car is pretty much empty. You need it to do a long journey in the relatively near future. Put it into fast mode. It will charge your car as fast as it can. If there's surplus PV electricity available, brilliant. But if not, it will just draw as much as it can from the mains to get your car charged as quickly as possible. Then there's eco mode. So eco mode will give a continuous charge to the car, but it will be limited to 1.4 kilowatts. So obviously we know that typically the electric vehicle charge point at home would be 7 kilowatts. So you can see you're basically reducing it by about down to about 20% of its maximum. But if there's more than that available from the surplus PV, then it will adjust the rate up and down to match what's available from the PV to prevent export from site, and that will be fed into the car up to a maximum of 7 kilowatts. And once the vehicle's fully charged, obviously it will cut off, and any surplus would then be exported back to the grid, and you get paid for that. If the surplus power falls below 1.4 kilowatts in eco mode, then the grid is used to make up the shortfall. So say you're getting 500 watts from your surplus from your PV panels, then 900 watts would be drawn from the mains to top up the 1.4 kilowatts. And then finally, there's eco plus mode. Eco plus mode is very similar to eco mode. The only difference is that that basically you don't draw anything from the mains. If there's not 1.4 kilowatts available, then this charge point just shuts down. That's the long and the short of it. You can actually set a limit of where you can sort of adjust it a bit, but that's the basic premise of it. So obviously in eco plus mode, you would get no charging overnight because obviously your PV array is not going to be producing anything overnight. So in terms of controls, there's lots of controls that you can have, such as those eco modes, such as the load curtailment we talked about earlier. But those are probably the 2 most important things. But you can see on the right hand one of these that it will give you a real-time estimate of what you're actually doing. So at the moment on this one, you've got 100% of your electricity is coming from green resources. 1.8 kilowatts is going into the car. 200 watts is going into domestic hot water. 1.4 kilowatts is going into the battery. 3.6 kilowatts is being harvested by the PV array, which is what's feeding in. Nothing is going in or out of the grid at the moment, and the house itself, all the domestic appliances are drawing 200 watts. So you can see those things together add up to 3.6 kilowatts, which is what's coming in from your PV array. And what would happen is if the sun got brighter and that went up to say 4 kilowatts, then more would be diverted into the car, and you'd charge your car a little bit quicker. So it really can be used to optimize and really, upgrade the performance of your PV. So it's a really good solution for that. Obviously, the real-time display can tell you whether you're importing, exporting, using backup battery, etc. in your house. So the last thing we're going to look at on the tech side is vehicle to grid. So as we know, the grid is coming under increasing strain from demands of electrics. So what vehicle-to-grid technology is aiming to do is it's aiming to help balance the grid load by allowing the battery from the car to also export electricity into the house to use for running appliances at peak times, and then obviously draw down power at off-peak times to help balance the grid. So especially with renewable sources of electricity, where you can't sort of turn them on and off, that's quite important. It does exist in a very, very limited capacity at the moment. So currently it's only viable for business users and typically fleet users. It's only currently supported by 2 models of vehicle. So it's there's a version of the Nissan Leaf that can support it, and there's a version of the Nissan NV200e, which is the little small electric minivan, which will support it. It requires its own suitable charge point, and it's only supported by some of the distribution network operators. So it's coming, but it's not quite there yet. And on today's prices for fleet users, it's offering a saving of around £250 to £450 per year per vehicle. So it's a reasonable chunk of saving if you can do it. So let's talk a little bit more about some of the paperwork that goes alongside EV charge points, because I know this is always everybody's favourite bit, is what will the government give us for fitting one of these things into our home? Well, the good news is there is the electric vehicle home charge scheme. So if you want to have an electric vehicle charge point at home for your electric vehicle, the government will give you a grant of £350 to have one, which is quite nice of them. You can claim for up to 1 charge point per vehicle and up to 2 vehicles per household. So if you and your other half go and both buy electric vehicles tomorrow, you can get £700 back from the government to have charge points fitted for those vehicles. They must be OLEV approved charge points. Most of the major manufacturers are OLEV approved, so no problem there. And you must use an OLEV approved installer. Again, there's quite a few OLEV approved installers around. And to be honest, I would use one of those anyway, just because you know that they're going to be properly trained and they're not going to be, hopefully not going to be cowboys. For more commercial installations, for sort of office buildings, there's the workplace charging scheme, which also provides £350 towards the cost of installing workplace charge points. You will notice these, if I'd done this a year ago, you'd have seen that the grants were a bit more generous a year ago, and they are starting to ramp them down a little bit. So just be careful that you don't get stung by leaving it too long. But with the workplace charge scheme, you can claim for up to 40 charge points across all the sites your company owns. It's open to businesses, charities, and public sector organisations, and again, must use OLEV approved charge points and installers. Okay, so the next one is time of use. So if you came to the battery storage masterclass, I talked about how you could use battery storage to sort of game the system a little bit to make use of cheap off-peak electricity. The good news is you can do the same thing with your electric vehicle. So on a nationwide basis, what we produce in electricity and what we consume in electricity has to be balanced. Now, that used to be quite easy when we had a whole load of coal-fired and coal-fired power stations, which we have fewer of now, and very little in the way of renewables, because you could basically, everything was turn off and onable. But unfortunately, wind power and solar power isn't quite turn off and onable in the same way, because you can't tell the wind to stop blowing and you can't tell the sun to stop shining. But what you can do is obviously you can make the grid adapt to what you're producing, and you can try and control demand, and you do that by changing the price. So the way that the system works is that wholesale electricity is charged in 30-minute blocks, and those blocks vary in cost. So as a consumer, we're quite used to having electricity that costs a certain amount as it comes out the plug. But actually, in reality, the wholesale cost of electricity varies quite dramatically. So to balance the grid, the wholesale cost of electricity will occasionally go negative. And that means they're actually paying you to take electricity away, which is quite nice of them. And obviously, if you've got something you can put that electricity into, like a electric vehicle, for example, then you can effectively charge your car for free. So time of use tariffs are becoming more popular. The ones that you probably may know of are things like the Octopus Energy Agile tariff, but they can be used to be exploited by EV owners. And finally, we'll talk about the permissions you need from your domestic distribution network operator. So the DNOs are responsible for ensuring that everybody gets a reliable electricity supply, but permission or notification of the DNO is required for all EV charge point installations. So what your installer needs to do is they have to do a maximum demand calculation for the whole installation. Now, if that whole installation comes to a total of less than 13.8 kVA, then the DNO must be notified within 1 month of connection that you've connected an electric vehicle charge point. Now, the reality is that most houses now are probably going to be over 13.8 kVA of maximum demand by the time you've put an electric vehicle charge point on, which means that you do need to inform the DNO prior to connection that that's what you're intending to do. So the sort of rural moral is it's always worth talking to the DNO before you start placing orders for things. In most cases, they won't have a problem with it, but it's just just good courtesy to help them ensure that everybody maintains a healthy electricity supply. Okay, so let's talk about the top 6 considerations for EV charging. Number 1, ensure your electrician has considered the appropriate earthing arrangements and safety arrangements. I mean, obviously, safety is always number 1 priority. Consider whether you need to allow for load curtailment to manage power consumption at peak times. As I said, a lot of the up-to-date electric vehicle charge points will do that anyway. Combine your electric vehicle charge point with PV to maximize self-consumption. Use time of use tariffs to maximize the savings. Take advantage of the grants. And finally, talk to your DNO and obtain all the relevant permissions before you start the installation. Okay, and this is just a little bit about what Mesh do. I won't bore you with it. I'm sure you've all seen this slide loads of times before. But obviously, specification of electric vehicle charge points comes into this 3rd package here, this sort of REBA Stage 4 package. We can detail the electric vehicle charge points, do those maximum demand calculations, etc. for you, and talk to the DNO on your behalf and get the electricity supply sorted out. So let's see if there's any good questions. So how much would an EV charger typically add to a home's energy use? What's the extra kilowatt hour per annum? It obviously depends upon your vehicle usage, but in terms of overall cost, your fuel cost per mile for an EV will be significantly lower than it would be with fossil fuels, whether that's petrol or diesel. We're replacing batteries every 3 to 10 years. Are they 100% recyclable? There's a number of different things that people are doing with recycling batteries, and some of those batteries are being used in things like building power supplies, etc., which is quite an interesting way of reusing them. Obviously, in a vehicle, you need very high power density, which you don't need in a building battery. So they bring sort of repurposed UPSs and things like that, which is quite an interesting one. And Catherine's also mentioned a video that was posted on MESHWORK recently about this. In an office environment, is there a way to show who uses electric vehicle charge points and how much? Yes, there is. There's a couple of ways, but there are electric vehicle charge points that will either charge you for the electricity that you use or require a PIN number to allow access. So you can monitor it that way by monitoring who's using what and how much power they're taking. So yes, you can meter it effectively. Yes, electric vehicle charge points can be installed internally in a garage, but to be honest, the number of people who actually use their garages for parking cars now is relatively small. So typically they're actually installed on the drive, but they can be installed internally. Ewan asking about on-street parking options. There are on-street parking options. The only thing you have to think about is cable management. Obviously, you can't have a cable running across a pavement, but you will see charge points that are sort of built in sort of posts that sit on the edge of the pavement on the roadside. There's a couple more comments about touching on terraced housing, etc. So we're involved in a development up in London at the moment, and with that, each house will have its own allocated parking space, and the electric vehicle charger for that parking space will be fed from the consumer unit in that house, and then there'll be a PIN, so that only somebody who knows the PIN for that house will be able to access power from that charging point, to ensure that people aren't stealing each other's electricity. Is there a preferred charging cycle for batteries? I wait till empty and fully charge, or little and often? Generally speaking, with most batteries, it's best to charge little and often. I think one of the older battery technologies that's not used in electric vehicles, that's not true of, but I think pretty much everything else, or lithium ion, lead acid, etc., they're all best to keep them topped up. Do you know if the government has plans for millions of parking meter charge points to be required? There is a whole office, the Office for low and power, OLEV. I can never remember what it stands for. Office for Electric Vehicles, I think it is. But there's a whole government department that's looking into the practicality of electric vehicles. The biggest risk, actually, from the government's point of view of electric vehicles at the moment is the fact that it will require a complete overhaul of how taxation is done on vehicles, because obviously fuel duty at the moment is a major revenue stream for the government. If there aren't any more questions, I'm going to say thank you very much for joining us this morning. It's been a little bit shorter than some of my marathons that I've done in the past with some of these, but thank you so much for your time, and I will see you at the next webinar. One thing I would say is please make sure that you sign up through the MESHWORK, because we won't be doing Eventbrite links anymore. Great, thanks very much. Cheers.